Okay, sorry, this will be the last video. Only 2 more problems. I apologize for this taking so long, but I think this will be a lot easier for you to work these problems instead of trying to remember what we talked about in class. You can always go back and reference these if you need to, since this is a little bit harder lesson. Example 8, a jet flew from New York to LA. A distance of 4,200 kilometers. The speed for the return trip, so we had going there and going back. So the speed for the return trip was 100 kilometers faster than the outbound speed. So I'm going to stop right here, and this is the outbound speed. I'm going to call this x1. You could call it s1 for speed. And I'm just going to call it 1 because it's the first trip. And this would be second speed. And so it says the return trip, S2, was 100 kilometers faster than S1, so 100 more than S1. If the total trip took 13 hours, what was the jet speed from New York to LA? So what it's wanting is this initial speed at S1. And we know total it was 13 hours. But we can't just say, well, S1 plus S2 equals 13 because this is my speed. So I'm going to need to convert the speed to time, and then I can add them up. Well, I know the total distance, and if you don't know this formula, it's okay, but you might want to learn it because we use it a lot. Distance equals rate times time. Distance equals rate times time. We want time, so time is the distance over. And so my outbound, my initial, my S sub 1, the speed is, well, S sub 1. So we can call it S, that's fine. Its time is going to be distance over rate. Well, I know the distance was, they both travel the same distance, right? And this is my speed. Same distance here, except my speed was different. So I'm calling S sub 1 S, just so we don't have to worry with that. And then this gives me my time for those two, because distance equals rate times time, so time is distance over rate. And then now I know, hey, these two times together equal 13. So trip 1 time, trip 2 time, together adds up to be 13. Well, that was easy to set up. This is a little bit harder to solve, but this looks very similar to something you should have seen back in the last section on how to solve equations when we have different denominators. In order to add, we know we need a common denominator. I have an S and a 100 plus S, so my common denominator is S times 100 plus S. So this needs a 100 plus S. So does this. This is a good review. This needs S. This needs S. So I don't need to worry about my right side yet. I'm going to go ahead at the same time distribute my numerator. So I have my 4,200 multiplied by 100, and then plus my S times 4,200. And then on the right side, I have the 4,200 S, and I still have my 13 on the right. Sorry, that's a little bit crooked. Okay, so that's a good start. This looks okay on top. I can combine that. Okay. Combine like terms on top. I'm going to multiply both sides by my denominator to get rid of it. And on the right, you get 13 times S times 100 plus 13 times S times S. And you can write that out in a couple steps if you need to. Now, in order to solve, we need to move everything to one side. I'm going to move everything to my right side. And then 1,300 minus 8,400 is 7,100. If you don't like the S's, you can totally use X's. These are really big numbers. If they divide through by 13, you're welcome to. This is going to be not only difficult to factor, but actually it's not going to factor cleanly. So I want you to pause right now, use quadratic formula to solve, and then start it back when you solve. Okay, so hopefully you solved, and you should have gotten two answers, 600 and around a negative 53.8 if you rounded to the 10th place. Well, my whole point was to find the speed. Speed is not going to be negative 53, not velocity can be negative. Speed's not negative, so I know the answer here was 600. And if I go back up to C, make sure I answered the question. Said if the total trip took 13 hours, what was the jet speed from New York to LA, which was my speed one? And so we did answer that. We just need to include units. So my answer is 600 kilometers per hour. Awesome. Last one. Ornithologists have determined that some species of birds tend to avoid flights over large bodies of water during daylight hours because air generally rises over land and falls over water in the daytime. So flying over water requires more energy. A bird is released from point A on an island 5 miles from B, the nearest point on the straight shoreline. The bird flies to point C on the shoreline and then flies along the shoreline to the nesting area D as shown in figure 5. You don't have figure 5. I'm going to draw it for you. Suppose the bird has 170 kilocalories of energy reserves. It uses 10 kilocalories per mile flying over land, 14 kilocalories per mile flying over water. That sounds crazy. Okay, and then it still asks us a couple questions. Right now I'm going to draw this for you. Reread this and point out some of the key parts. If you'll just take it bit by bit, it's not near as awful as it actually looks. It's just a lot of overwhelming words. Okay, here's your lovely picture. You would be given this, so don't worry about that, but hopefully you could draw it. If you scroll back up, it said they were 5 miles from the island to the shoreline and then 12 miles from B to D. And so what the bird did was it flew this way and then flew this way. So we knew it flew a diagonal here, and then it also flew this way. And it tells us several things. It tells us total energy is 170, and this already determined your x for you. It's the distance from B to C. The point was to find the low. A is to find where point B should be. We use that 170 kilocalorie of energy. And we know it uses 10 over the water, which is going to be this part here. And that it uses 14 when it's over land. Now that's not total, that's for how much the distance is, so we need to find out the distance. So we're going to write these distances in terms of x, because remember, we defined our variable. X is the distance between B and C, but we need to define everything by the variable. Well, if I know this is x, I know this is 12. The distance from C to D here has to be 12 minus x. Now here's a little bit trickier. I need to find the distance of my purple here, but of course north and south, the two different directions make a perpendicular angle, so you can use Pythagorean theorem. You know, this is 5, this is x. You'd say 5 squared plus x squared equals, I'm just going to call this r for now, r squared, and I want to solve for this distance. Well, 5 squared is 25, or just to make that a little bit easier, I'm going to say x squared plus 25. So that is the distance here. So 10 kilocalories is the energy, and the distance is x squared plus 25. We don't know what x is, so we can't finish solving. But we found both distances and both energy. So we know that it took 100, or we need to take 170 total, 10 here for each of this, and 14 for every bit of this. So he used 10 kilocalories times this distance. This is the amount of energy in water, and the energy in land is 14 times the distance. he spent on flying over the land. In total, we need to make these equal 170. This one is a bit harder, but make sure you're following along step by step. I have no doubt that you can do this. Okay, and so now we need to solve. We need to get rid of that root, so let's get everything away from it. Okay, going back over this problem and reading it, I just realized I made a mistake, so we're going to fix this. Hopefully you already caught it. Apparently you can read it. It uses 10 kilocal energy flying over land and 14 over water. I said it backwards, so this should actually be 14 and this should be 10. So I'm just going to come through and change that. I apologize. Hopefully you caught my mistake. So I just got everything backwards. So this should be, so you can see in red where I corrected it everywhere. And now I'm going to continue solving for x. So I'm going to distribute negative times a negative is a plus. Okay, now I have this isolated. I still have a coefficient, and you can divide by that 14 if you want. But we can go ahead and square because I don't have any sort of addition term there. This would give me 14 squared times the square and square root cancel. And then over here, I'm going to have to FOIL. And then this right side, I'm going to distribute. Okay, so we all distributed, moved it all to one side. You're welcome to divide through and reduce the sum. Can't really be factored, so use quadratic formula. Stop that and do that now. And then you should get two answers. 6 2/3 are 6.6 repeating, and then 3 3/4 are 3.75. So it could be either one, and we don't know. So your answer is, hey, that it can be either one. It could be 6 2/3 mile, or 3 3/4 mile away from B. And either one would allow the bird to use exactly his reserve energy of 107 kilocalories. Okay, go back up to B. Does the bird have enough energy to fly directly from A to D? Well, if I resketch this was 5, this was a total of 12. So if I do Pythagorean theorem, you'll determine that from A to D, he's going to need to be able to fly 13 miles. And it said it took, this is all over water, and it was 14 kilocalories over water. So 13 times 14 is 182 kilocalories. Does he have enough? No, he only has a reserve of 170. So you'd say, no, it's more energy than the bird has. Or whatever. No, he needs, 12 more to answer that. Okay, thanks for working 1.6. Now do your homework and email me or come see me with any questions.